Now I am going to boot the system. But before that, I will show you the computer I have standing here. I have 6 HP 1000, 2 model A400 and 4 model A990. I have some disks, a printer, some DAT and 3 terminals. I will only set power and boot this computer here. But just before we do that, I think we should look into the back plane of this computer. On the right we have the A990 CPU card, then 3 memory cards, so a SCSI card connected to a disk, a SCSI card connected to a DAT tape, a 816-bit parallel card. I'll talk more about this special card much later. Then a 1204D 8-channel multiplexer card. Then another SCSI card for 1 more disk, and here 2 more not connected SCSI cards. They can be connected to 2 more disks. So here are 3 empty slots. The last 2 here cannot be used. They are reserved for some extra power supplies. 1 card, a power jumper card, it must be installed. There must not be any gaps between the cards. That is due to the interrupt structure, where the card that is sitting closest to the CPU can block interrupts from the cards further to the left in the chain. Therefore, you should mount cards having the highest hardware priority closest to the CPU, typical a disk controller card. Each card has a select code which is set up on the card dip switches. One and only one multiplexer card must have its VCP dip switch activated. A HP panel like this would normally be connected to the multiplexer card. But here we use our own multiplexer panel, which also contains balanced output amplifiers supporting the 4-to-2 standard. You can find a lot about setting up the HP 1000A series in the manual on the web. Now I will turn the power on. If everything goes well, we will get a VCP, the virtual control panel, on the terminal. It was a success. The VCP information came up. If no information had come up, you had to refer to the LED display on the CPU card and the corresponding error codes which are shown on the back plate cover. The VCP program has tested the CPU and the connections to the controller cards, etc. We see the result here. There are no errors reported by the VCP, and there is 24 MB memory. In the column to the left we have the I/O card ID type. 150 is a SCSI card, 106 a multiplexer card, and we can see the VCP switches activated. I can now boot the HP 1000, but I want to type ? First. Here you can see some VCP guidelines. I will tell you a little about the boot process. You can see that the VCP can perform various functions in addition to the boot function itself, that is several tests of the HP 1000. If you want, for example, to boot from a DAT, you can enter %BMT and the address of the tape type. But I will concentrate on booting from disk. To do so, we have to have the operating system RTA on disk, and in the leading track on the disk, that is the boot track, the program boot text must be installed, and there will also normally be a boot command file and a welcome file. Furthermore, to boot you can specify the select code on the disk I/O card, the unit code on the disk drive, and the name of the boot file. It can be specified in the boot command line to the VCP. If you write only %BDC, the VCP will use the default value, That is, for the SCSI card and the HPIB card, select code 27. For the SCSI disk, it is unit code 6. For the HPIB disk, it is code 2. The default name of the boot command file is boot.cmd, but notice it can be specified a different name in the boot command string and thus boot a different configuration of the operating system. It is frequently used for the configuration changes. Most often, the HP delivers the operating system, that is the RTA software, etc., on a partly configured disk, a so-called primary system, a system which can be started immediately with the default parameters. I will now enter Start BDC, and the VCP should boot with the default values. What happens next? Nothing. Nothing at all for a long time, a very long time. It may take several minutes. Be very patient. If an error occurs, the VCP may come up with a loader error. The reason for the very long time delay is probably that the VCP, which doesn't know much about the system configuration, is trying its way with different configurations. Be very patient. Now, here it happens. The boot command file is run by the Booting program. I have taken a screen dump of the boot command listing so we can have a steady picture here. Here you see the top of the boot command file. You can see it's revision 6.21. That is the latest revision of the operating system. And there come a date. Then you have the MI order. You can ignore that line. That is only if you have a disk mirrored system, but that is what we have here. Then we define the name on the operating system itself, the SV order, and also the name of the snap file used by the loader. And then we mount all the logical disks. Here we have the next part of the boot command file. As you can see in the top, we are still mounting disks. I should say that the location and the size of the disk are defined in the table in the operating system. So if you make any change here, you have to generate a new operating system. That is, however, relatively easy to do. Then we are restoring a lot of program. Restoring we are to take the parameter for the program code and store it into the ID segment of the operating system. That includes also the address of the program code so that the program can be very fast loaded. Here you see the last part of the command file. At the top you can see we are still restoring programs. Then the command st1. It points to the welcome1 file. That is a command file which starts up after this command file. In this command file you can, for example, set the baud rate of the multiplexer and things like that. Then we define the size of the swap file, and then we restore two programs. That is, we transfer them to memory as resident programs. And then we wait 3 minutes. Why 3 minutes? Nobody knows. Now the welcome1 command file is started. I have listed the file here. As you can see, we are running some programs, we are copying a file, we are setting the timeout for the DAT tape recorder. Here you see the last lines in the same command file. As you can see, we are setting up the baud rate on some multiplexer channels. Then we are running a little time program, HP time, so the user can key in the date and time because there is no more power on the clock battery. And then we display a little welcome message. So now the system is booted. Before we are leaving this boot section, I think we should take a quick look at the disk space and how the disk is organized. To this purpose, I have used the program Freeze. You can see I am running Freeze with the -S here. That means that Freeze will list all the disk which is generated into the system and mounted, and they are listed in the mounting order. You can see the system disk up here, LO11. It's a small disk of 128 megabyte. It's a handy small disk because you can easily save and restore it on tape, for example. You can see it has a reserved area here that is for the boot track. You can see the next disk is a double size, then double up, then double out. The largest disk size is about 1 gigabyte. In all, you can see here there are 11 gigabyte. In fact, the disk drive is on 18 gigabyte, but we never use more than the 11 gigabyte. Notice the free space area down on disk LO20 to 23. There are no free space at all. The reason for that is that here have been a patient database with sensible data, and then mean to erase that, we create files here and write binary data randomly into the whole file. This to be sure that we are erasing all sensible patient data. This is a layout we use on nearly all our lab systems with this SCSI disk.